Let's talk about the game of bingo. We've all played the game of bingo before. Here's a typical bingo card. It has 5 columns with letters B, I, N, G, and O. Each column has 5 numbers chosen from 15, G4G15 possibilities, all right? So for example, column B, you have 5 numbers that are in a random order, numbers that are between 1 and 15. Column I has 5 numbers between 16 and 30, and so on. Here, let's play a quick game of bingo in case you haven't played before. I'll start with the free space. And then let's see, B7, ooh, I've got that. B1, yes, I've got that. G49 didn't have that. G54, I've got that. O61, yes. G48, yes. N37, no. I25, hooray, bingo. Okay, so you get a bingo once you get 5 horizontal or 5 vertical or diagonal. We'll ignore diagonals today. The question is, what's more likely to appear first on your card? Okay, you've got this big bingo tournament this weekend. You want to practice it, and you want to ask yourself the question, what's more likely, that you get a bingo horizontally or vertically? What do you think? No, well, no, it's 50-50. It's equally likely because you're just as likely to get these 5 completing your card as those 5 completing your card. You're just as likely to get this row of 5 as this column of 5. They're equally likely, but now you walk into the bingo tournament. It looks just like this. Everybody has like a card in front of them with like 6 bingo cards on it. There are like 1,000 cards out there. And we play bingo one more time, and this time we ask ourselves, what's the chance that the winner is horizontal versus vertical? And now, surprisingly, it is horizontal, and by a lot. Like more than twice as likely that the winning bingo will be horizontal than vertical. This is what I call the bingo paradox. In the game of bingo, when there are many cards in use, it is much more likely for the winning card to be horizontal than vertical. And this is true whether or not we're playing with the free space. I'll ignore the free space going forward here. And the question is why? Can I give you some intuition as to why horizontals are more likely than vertical? And the way to do this is to take this to an extreme. Instead of playing with 1,000 cards, let's imagine we play with every possible card in the universe, right? How many is that? Roughly 6 billion cards. I call it galactic bingo. Imagine every creature in the universe has their own bingo card, okay? And now suppose we're playing galactic bingo, and the first 7 numbers look like this. By the way, these are Fibonacci numbers. And I'll announce that if you love Fibonacci numbers, that the International Conference on Fibonacci numbers will be this summer, this July 8 to 13, Fibonacci, at Harvey Mudd College where I am. So if you're interested, come. Okay, anyway, is it possible at this point for any card to have a bingo? No, because you can't have a vertical bingo because no letter has appeared 5 times, right? You can't have a horizontal bingo because the letter O has not yet been represented, right? But now suppose the 8th number was O75, all right? Now that since every letter has appeared, there has to be at least one card with a horizontal win, but there's still no cards with a vertical win. So in galactic bingo, this sequence would generate a horizontal win on the 8th draw. So in galactic bingo, with lots and lots of cards out there, a horizontal bingo occurs as soon as all 5 letters appear. A vertical bingo occurs as soon as some letter appears 5 times. And now I ask the question, what is more likely to happen first? That all 5 letters appear, or some letter appears 5 times. Now the problem isn't so symmetric anymore, right? And now your intuition would be correct that you're much more likely to see all 5 letters appear than some letter appearing 5 times. So, for example, if I asked what's the chance of this happening, let's say the game of bingo went spectacularly fast. It only took 5 draws. You could calculate that the probability of a vertical win, let's say you started with B1, the next 4 numbers would all have to be in column B, and that's their probability. Or if you started with B1, the next number has to be something that's not in column B, say it's in column I, then something that's not in column I. That's much more likely, indeed 50 times more likely. After the 5th draw, the counting becomes more complicated, but for those of us who love combinatorics, we can do it. We do calculations that look like this. I won't explain it here in the 1 minute remaining, but it's something doable. You got to look at 70 cases, and you can do it. And the punchline is that when playing galactic bingo, the probability of a horizontal bingo is a little over 75%. That is, as the number of cards gets larger and larger and larger, a million cards say, we get really close to 75% chance of a horizontal bingo. With 1,000 cards, it's like over 2 to 1, twice as likely. If you're still not convinced, instead of going super big, let's go super small. Let's play a game on a 2x2 card. It's called BO, all right? There's only 4 BO cards in the universe, and obviously if you're playing by yourself, there's only one way to finish. It's equally likely whether you get horizontal or vertical. But now in galactic BO with all 4 cards, notice that if the first draw is B1, if the next draw is B2, then everyone's a winner with vertical. If the next draw was O3, well, then we have 2 winners that are horizontal. If the next draw was O4, we'd have 2 winners that were horizontal. So even in this very small version of the game, we see that there's a 2 to 1 advantage for horizontal versus vertical. If you want to see more details, see the article in Math Horizons, or if you don't get Math Horizons, see it in your grab bag. Thank you all very much.